Okay, good afternoon, everybody. My name is Gary Bolton from the National Nuclear Laboratory. We're hosting this. I'm hosting this webinar with Lindsay from NNL offices in Warrington. I'd like to welcome you to this second of 5 webinars that we're putting on to provide background information on the NDA's annual PhD Bursary Call. Just a couple of housekeeping matters. I'd just like to remind you, this webinar is being recorded and it will be made available via NNL's website over the coming days. And it is an open forum, so I would just ask you to respect the speakers when you're asking questions. There is a possibility that they may not be able to give you an answer. So those of you joining on the BlueJeans software, questions can be submitted via the software. We're doing the webinar from different locations, so when a question comes in, I'll read it out to the presenters and we'll get an answer back to you. But now I'd like to hand over to Rick Short from the NDA to provide a short introduction.
Okay, thanks very much for that, Gary. As Gary said, I work for the NDA. I am the research manager, and I'm also the strategic authority for university interactions. So I look after all of the sort of PhD projects that we sponsor and the bursary scheme. So if we can just move on to the first slide of the presentation. Just a quick outline of what we're going to do today. I'm going to give you this brief introduction. It's going to last about 5 minutes, and then we'll move on to the technical leads who we've got here, which is Nigel Donaldson, who's going to talk about the spent fuel theme of the call, and Nick Slater, who's going to give us a brief talk about the nuclear materials aspect. And then after that, we'll have an open question and answer session for anybody to ask for clarification or ask any questions of the technical experts we've got in the room they wish. Okay, so we move on to the next slide. What are the key reasons why NDA support PhD research? Well, one of the main reasons we support it is for the maintenance and development of the key technical skills that we're going to need to carry out the NDA's mission over the coming decades. It's going to take a long time to go about decommissioning all of the civil nuclear sites in the UK. We need to make sure that we've got the technical skills available to help us do that, and that means keeping not only the industry supplied with good quality candidates who can come in and do that kind of work, but we need to keep the supply chain supplied with them, and we need to make sure that there are plenty of academics who have got the background that they need to teach future generations of students and get them skilled up to the level that we need to help us carry out the mission. A lot of the research that we do is about providing a fundamental understanding of the technologies and the processes across the NDA estate. And that's especially true in this particular theme as far as sort of understanding the long-term behaviour of the fuel that we've got stored and the nuclear material that we've got stored. And a lot of the work that we do for PhD research is generally supporting the lower technology readiness level applications. So it's really looking at the fundamental understanding and technology readiness levels 1 to 3. And obviously that will feed into the more sort of innovative levels that we've got that we support, and then the development and the actual application of the final end user of the final end uses of these technologies on the sites, which are the sort of technology readiness levels 6 to 9. And knowledge transfer is a big aspect of our PhD research as well. All of our PhD students get an industrial supervisor, and that industrial supervisor is there to not only make sure that the student is well informed about the issues of interest to the industry and to keep their project on track, but it's to take the learning that's generated in the academic institutions back into the industry as well, and make sure that the industry is aware of the opportunities that the academics are generating. If we can move on to the next slide, please. I've just put this in as a sort of reminder to help you when you're preparing your bursary applications, and it's sort of mainly there to demonstrate the differences between the kind of work that the NDA will fund directly from our direct research portfolio, as opposed to that the SLCs are going to fund. So the areas in which we're looking for proposals for the NDA portfolio are around the maintenance of key skills and capability, as I said before. We're looking for applications that are innovative, and that will certainly help when you're putting your applications together. And I think this is particularly true of the spent fuel and nuclear materials area. We're looking for applications that will help us to make the strategic decisions that we need to make in this area going forward. And a lot of that is about providing, again, that understanding, that fundamental understanding of the behaviour of the spent fuel and nuclear materials that we have in our inventory. As opposed to, and that's all as opposed to the SLC funded R&D, which tends to be much more about improving the baseline for the site cleanups. So that means that the SLCs tend to fund R&D that is more sort of plant specific, it's needs driven, or it might be to maintain specific capabilities on the sites themselves. So that's sort of providing the next technical leads for this particular process or plant. And they're the kind of projects we would expect the site license companies to fund, as opposed to funding them through the direct research portfolio. And then if we just move on to the last slide there, I just put this in as a general reminder to everyone about the importance of R&D. The ultimate aim of us doing this kind of research and development is to try and reduce the numbers that we have and that we regularly report in the NDA annual report. The timescale for the cleanup of the civil nuclear sites is the current baseline goes out for more than 100 years, and it's going to cost well over £100 billion to do this. We've got the opportunity by funding this kind of R&D to reduce those numbers. We can make big efficiency savings if we can apply a lot of this research that we're doing and develop new technologies. And we can save a lot of taxpayers' money to spend on sort of useful projects, hospitals and schools, etc. And I think we've got a real opportunity to do that. Even a small saving, even a small percentage saving, can make a big difference in terms of the overall financial cost. Okay, so that's pretty much all I wanted to say. I'm going to pass you over now to Nigel, who's going to talk first about the spent fuel aspect of the spent fuel and nuclear materials thing.
Okay, thanks, Rick. I think it's probably going to be a better use of people's time and more effective in terms of giving information if I leave people to read the presentation in their own time, and I'll concentrate on giving a little bit more information about the background and the requirements of the themes for this year's Bursary Call for spent fuel. Alongside its decommissioning activities, the NDA is going to be responsible for some considerable number of decades to come for some of the UK's spent nuclear fuel. In particular, it's going to be responsible for managing the AGR spent fuel which accumulates from future operation of the AGR reactors when reprocessing at Sellafield has stopped. And it's also going to be responsible for managing historics of legacy material which have been used in the UK's research and development programme, and also potentially some of the material from Magnox reactors which will not be appropriate for reprocessing and which arises from decommissioning activities along the way. So, in essence, there's a considerable quantity of material going to have to be stored, and ultimately the plan is that that material will be disposed of in a repository, an underground repository in the UK. In between times, the fuel clearly will need to be safely stored, and that may require a number of things to be considered along the way. And potentially, depending on the nature and requirements of the repository, there may also be some treatment requirements or packaging requirements which the fuel will need to undergo. So, starting to focus in on the areas that we have, much of the fuel is expected to be of sound integrity. It will be fully contained and is expected to maintain that containment over many years and through into the timescale when disposal is expected. However, there's a large quantity of material and it's possible that activity from the fuel may leach if the cladding deteriorates, or alternatively, it's possible that there may be radionuclide seepage into the storage area if, for example, conditions change, releasing latent inventories of material from the pond structure or machinery, or even in some cases it's been the case that small quantities of radioactivity have been introduced by contaminants associated with imported furniture and other items, and not the fuel itself. Therefore, there is a need to consider what may assist the operators in future in understanding whether radionuclide fugitive material is being created in the storage areas, and to identify that not only at a very early stage, but also to help in understanding what the source of that material might be. The AGR fuel historically has been associated under certain conditions with very localized failures which have given rise to fugitive radionuclides. Experience over many years has now indicated that the proposed storage regime of dosed water does prevent that mechanism. And whilst that confidence is based on a considerable number of years' experience, it's going to be helpful to the NDA and the future operators if we actually understand the mechanisms at a scientific level better, to be able to predict why that mechanism for corrosion inhibition works and under what conditions that could be prejudiced. Some fuel, which the NDA will be required to store, is not of sounding. Quite the converse. It's actually been sectioned or damaged during experimental procedures historically, or in the case of some metal fuels, it can degrade under certain conditions, and there will be degraded material which has to be stored. In those circumstances, what we're interested in is what forms of containment may be suitable for storing that material in the long term, and in particular how that containment may be maintained and supported by managing conditions which can challenge it. In particular, if the fuel contains some moisture or is associated in some cases possibly with organic materials, we can get radiolysis. If chlorides or other aggressive species are present, we can get corrosion. And therefore, one of the things that we are particularly interested in is understanding whether there may be improved packaging systems which could be used to isolate spent fuel from the storage environment, whether that's dry or wet, and also whether contained fuel can be managed in a way where moisture or other material present can be prevented from generating radiolytically induced pressurization or alternative mechanisms which could prejudice the actual containment performance itself. We don't know at this stage what the disposal requirements for damaged and degraded fuel might be. We don't know at this stage, therefore, whether the materials in their form currently will all be suitable for direct disposal. And this particularly is the case where heavily degraded and particulate material is present from historic operations and experimental programs. And therefore, we don't know the extent to which alternative packaging or stabilization of the fuel material might be required. And therefore, one of the things that we are keen to consider is whether there are novel proposals to stabilize the material such that possibly during storage, but particularly perhaps during preparation for disposal, the propensity of the material to interact with its environment, whether that's the near-term environment within the repository or the storage environment, can be reduced. I think that's pretty much covered the key areas been identified in the presentation and are present in the themes. As I say, particularly appropriate to the storage period in terms of a contingency is the ability to recognize any deterioration of the fuel, either by fugitive radionuclide release or conditions which could actually promote very early stage, and therefore proposals to detect those incipient conditions by appropriate mechanisms, and ideally to be able to map the changes in such a way that any source of a problem can be easily identified, will certainly help make the operator's contingency response mechanisms much more effective in future than relatively wide-scale responses which are currently required to deal with any unforeseen conditions within the storage facility. That applies not only to wet storage facilities, which are currently envisaged for an interim period and possibly the whole of the duration through to disposal, but also possibly dry may be used as an interim arrangement, either as an alternative to wet storage or possibly as a buffer storage provision between preparation of the fuel for disposal and actual emplacement.
Right. Good afternoon, everybody. I'm Mick Slater, Fuel Cycle Manager at the Nuclear Decommissioning Authority, and I'm going to talk briefly about some of the research work we might be interested to support our plutonium program. We store large quantities of plutonium at our site in West Cumbria, and the material is stored in nested stainless steel canisters. We've got a program with the site where we have a safe storage program where those canisters are planned to be stored for a number of decades, and all of the canisters have got a notional design life. And if we do nothing, what we'll end up doing is having to repackage this material when the cans reach their notional design. But one area of research that we might be interested in is work around non-destructive assay of the cans, so that maybe rather than just go for whole-scale repackaging when a time expiry date is met, carrying out some kind of non-destructive assay to get a sort of an engineering or science view on the state of the can and whether we could actually substantiate its use for a further period of time. So non-destructive assay of plutonium cans in storage would be of use to us, because it may help us to come up with a more cost-effective means of storing these over a number of decades, rather than having to just repackage them all. The other areas of work we're doing in parallel to safe and secure storage, we're actually looking at what we do with our plutonium stocks in the long term, and there's information published on this on our website and also on the formerly DEC website. Essentially, government policy at the minute is to examine the potential reuse for plutonium as MOX fuel. So we would be interested in any sort of research topics that played into that theme, which is essentially converting the plutonium into a mixture with turning into fuel pins and then irradiating that in some form of new build reactor that may be built in the UK in due course. So we're interested in themes associated with plutonium reuse. The other theme that we're particularly interested in is that some of the material we've got, we already know may not be suitable for reuse. And we're exploring various techniques that we might use to condition that for disposal. There's a variety of techniques that can be used. As an example, hot isostatic pressing is one area of work that we're interested in. We'd also be interested in any other ideas on immobilization techniques that we might be able to use. Initially to treat the material that we know is not suitable for reuse, but also should government decide as a later date that they don't really want to do reuse and decide that plutonium is a waste rather than an energy source, then we may be looking for a solution that would condition all of the UK stocks for future disposal. So that's a quick run through the kind of things that we're interested on the plutonium front. I'd be happy to answer any questions on that later on.
Okay, I think that's about it from us in terms of what we're going to present today. So happy to take any questions. Okay,
it's Gary Bolton here back at NNL in Warrington. So thank you very much to our speakers. If anyone has any questions, please do type them via the Blue Jeans facility.
Gary, Steve Walters here. I'm not on the computer. Can I ask a verbal question? Mick, your data points aren't in the slide set. Will you be adding to the slide set so that those not on the call today can see your areas of concern?
I think they're all listed fairly comprehensively in the Bursary advert, Steve.
Okay.
For anybody who, I'm presuming everyone must have seen that, otherwise they probably wouldn't have got the details for this webinar.
Yeah.
But,
okay.
I have a question about, sorry, this is Rob Lindsay from Manchester. I have a question about the topic of radionuclide leakage into the stored material. This is stored material in ponds, and is that adsorption onto surfaces or absorption into the material itself?
Good question.
Do you know?
The fugitive material that I'm talking about generally is if it derives from fuel, it's generally dissolved material which goes into the water. If the material originates from some latent source, it can be a variety of things. For example, cesium is known to what is generally called plate out on metal surfaces, and as I understand it, it becomes associated with the top few, probably fractions of a millimetre or millimetre or two of the metal surface. And if conditions change, then it can be released back into the environment, and it can either bleed into the environment if it's a dry environment, or it can become redissolved into the environment. Other sources can behave in different ways, and at this stage, I think it's a case of, rather than presuming that they will occur, not discounting that historically seen scenarios could not occur. So, for example, alpha activity from historic material can be transferred into the storage facility. And in those cases, there is some conjecture as to whether that material is colloidal or dissolved, and to some degree, depending on the nature of the colloid, the two are actually indistinguishable insofar as the colloid material acts as if it was dissolved in respect of how it may spread. So at this stage, I'm not making any presumptions, Rob, about how that material is going to be distributed. I think what I would say is, if the target was to identify better methods of establishing a source from an incipient fuel leakage rather than some form of historic source, then the focus would generally be on the more soluble radionuclides such as cesium.
Okay, thank you.
Okay, do we have any other questions either on the line or you can type them via Blue Jeans? Okay, we haven't received any other questions here, so I think we'll draw things to a close. So I'd just like to remind you the deadline for submission of PhD proposals is Friday the 21st of October. And we hope you found today useful. Thank you to the speakers, and thank you for everyone for joining us today.
Thank you.
Thank you.
Bye-bye.
Thank you.
Thank you.
Thank you.